All right, so get ready for this one because it's 1908.
Oh, boy.
Siberia. Imagine this.
Okay.
Vast forests.
Mm-hmm.
The sun's barely even up, and then
Yeah.
out of nowhere,
Uh-huh.
a blue light brighter than the sun tears across the sky.
Wow.
That, my friend, was the Tunguska Event.
Wow.
An explosion that flattened 80 million trees.
Oh, my goodness.
80 million trees.
Yeah.
Over an area twice the size of Rhode Island.
Wow.
It's a true mystery.
Yeah.
And the weirdest part, no crater. It's like something out of the X-Files.
Yeah, you're right. The lack of an impact crater is one of the most baffling aspects of this whole thing.
Really?
Yeah, we're talking about the largest impact event ever recorded, an explosion that sent shockwaves across the globe.
Really?
Yeah, and yet no gaping hole in the ground. That's where the real detective work begins.
So we're talking like cosmic mystery, right?
Absolutely.
Where do we even start? I mean, we don't have any video footage,
Right.
but we do have something just as incredible.
What's that?
Eyewitness accounts.
Oh, wow.
Imagine hearing these stories firsthand.
Yeah.
People describing being thrown back by an invisible force.
Ooh.
The feeling of intense heat,
Yeah.
even miles away.
Wow.
Windows shattering from the pressure.
These accounts, often fragmented and passed down through generations, they give us a glimpse into the sheer terror this event must have inspired.
I bet.
For example, one Evendiki tribesman described it as
Okay.
a second sun,
Wow.
so bright it hurt his eyes.
Really?
Yeah.
It's hard to even fathom that.
Mm.
It's amazing how those firsthand accounts really bring it to life. It's
Yeah.
like reading a chilling news report from the past.
Yeah.
Speaking of which, I found this account from a local newspaper, Siberia.
Okay.
They talked to someone in a village over 130 miles away.
Wow.
And get this, they wrote, at 7:43 a.m., the noise akin to a strong wind was heard. Immediately afterward, a horrific thump sounded, followed by an earthquake that shook buildings as if they were hit by a large log.
Oh, my goodness.
The sky, at first sight, appeared to be clear. There was no wind and no clouds. It sends chills down your spine.
It is fascinating because while the sky seemed clear at first,
Yeah.
this account, along with several others,
Okay.
they describe a strange ashen cloud appearing on the horizon just minutes after the event.
Really?
Yeah.
So like right after it happened.
Yeah, and this detail lines up perfectly with what we'd expect to see after an atmospheric explosion.
Okay.
Kind of like a giant dusty echo of whatever just happened.
And the effects weren't just visual.
Right.
This thing was so big,
Yeah.
it set off seismic stations across Eurasia.
Wow.
We're talking as far away as the UK.
Oh, my goodness.
And here's another head-scratcher.
Okay.
People reported unusually bright skies for days afterward.
Oh, really?
Some even took photos at midnight without any flash.
You know, those glowing night skies, they weren't just a pretty sight. They were actually a crucial clue for scientists.
Really?
Yeah, revealing how much debris was blasted into the atmosphere. Think of it like this.
Okay.
When this object, whatever it was, exploded,
Uh-huh.
it threw tons of dust and ice particles into the air.
Yeah.
And those particles were so high up, they caught the sunlight and scattered it around,
Wow.
making the sky glow even at night.
No way.
Yeah. We saw something similar, though, on a much smaller scale after the Chelyabinsk meteor in 2013.
Okay.
Yeah. Really highlights the interconnectedness of our atmosphere.
Wow.
How events like this can have global repercussions.
It makes you realize how interconnected our planet really is.
It really does.
Okay, so we've got a massive explosion,
Right.
flattened trees, no crater, glowing skies. Sounds like we've got a real cosmic whodunit on our hands.
We really do.
But what exactly caused it?
Right.
Was it a solid chunk of space rock, like an asteroid?
Possibly.
Or something more elusive, like a comet?
That, my friend, is the million-dollar question.
Um,
Let's put on our detective hats and dive into the evidence for each suspect, shall we?
Let's do it.
So imagine this. It's years after the event.
Okay.
Scientists are combing through the blast zone,
Right.
and they're finding these tiny, almost microscopic spheres
Okay.
scattered in the soil,
Wow.
even embedded in tree resin.
Tree resin, like amber.
Exactly.
That's pretty wild.
Like these tiny time capsules preserved remnants of the explosion.
Wow.
And when scientists analyzed these spheres,
Okay.
they found something really interesting: high levels of nickel and iron.
Isn't that what meteorites are made of?
You got it. That discovery was a major win for Team Asteroid.
Right.
And there's more. The way these spheres were distributed on the ground in this butterfly pattern radiating out from the epicenter. It matched what computer models predicted for an asteroid airburst.
Hmm.
So for a while, it seemed like case closed.
But there's always a twist, right?
There always is.
Okay.
Back in the 1930s, a British astronomer named F.J.W. Whipple proposed a radical idea.
What's that?
What if it wasn't a solid rock at all, but a comet? A giant ball of ice and dust.
Okay, that's a pretty different suspect. How would a comet explain things like no crater and the glowing skies?
Well, unlike a metallic asteroid,
Hmm.
a comet entering the atmosphere at such incredible speed would heat up rapidly and essentially vaporize.
Okay.
That could explain the lack of a crater.
Right,
It's like ice melting in a hot pan.
right.
It leaves behind a trace, but not a solid chunk.
Okay.
And the glowing skies.
Yeah.
Same idea.
Oh.
All that vaporized ice and dust from the comet would get scattered high in the atmosphere,
Right.
creating those brilliant, long-lasting night skies that people reported.
I'm starting to see how Team Comet could be on to something. But we can't talk about comets without mentioning Comet Encke, right?
You're ahead of me. Comet Encke has long been a person of interest in the Tunguska case. You see, this comet is responsible for the Beta Taurids, a meteor shower that happens every year in late June,
Okay.
the same time as the Tunguska Event.
Interesting. So like a cosmic coincidence.
That's what a Slovak astronomer Ubor Kresak proposed back in the 1970s. He believed that the Tunguska object was actually a fragment of Comet Encke. He even showed how the trajectory of Comet Encke lined up with the estimated trajectory of the Tunguska object. It's pretty compelling stuff.
Wow, it's like a cosmic lineup.
Right.
And I'm no astronomer.
Sure. Wouldn't a comet being mostly ice have disintegrated much higher up in the atmosphere?
That's a great question. And you've hit on a point that's been hotly debated among scientists. In the 1980s, astronomers Zdeněk Sekanina argued that a cometary fragment simply wouldn't have survived long enough to reach the lower atmosphere and create an explosion of that magnitude. He believed the object had to be denser, something more like a rocky asteroid.
So we're back to square one.
Well,
Team asteroid versus team comet.
not quite. You see, as much as we love a good debate, science keeps moving forward.
Right.
In recent years, researchers have been running increasingly sophisticated computer simulations,
Okay.
taking into account things we've learned from more recent events, like the Chelyabinsk meteor.
And those simulations are pointing us towards a more likely culprit. A stony asteroid, probably around 160 to 260 feet across, entering the atmosphere at just the right angle and speed to create the Tunguska event.
Okay, that makes sense. But then what about the lack of a crater?
Right.
I thought asteroids left craters.
They usually do, but remember the Tunguska object exploded in the air. Scientists believe it likely detonated several miles above the surface. The force of that explosion, instead of digging a crater, would have created an intense downward pressure wave. Think of it like this. Imagine holding a watermelon over a trampoline and dropping it.
Okay.
It doesn't punch a hole through the trampoline.
Right.
It explodes outward,
Yeah.
leaving a wide area dented, but no single deep impact.
Okay, I'm with you. But then there's Lake Checo.
Right,
Didn't some scientists think that that might actually be the impact crater?
right. Lake Checo.
Oh.
This small, bowl-shaped lake just north of ground zero was a major contender for a while.
Really?
Yeah, it's like the universe was pointing an arrow right at it. Early studies of the lake bed show this conical shape,
Okay.
almost like a mini crater.
Wow.
And instruments even picked up strange magnetic readings, suggesting a large object buried beneath.
So case closed, another win for Team Asteroid.
Well, hold on. That's the beauty of science. Just when you think you've got it all figured out,
Right.
new evidence emerges.
It always does.
In this case, researchers took a closer look at the sediment layers at the bottom of Lake Checo.
Okay.
By analyzing these layers, they could estimate the lake's age.
What did they find?
Turns out Lake Checo is far older than the Tunguska event,
Really?
probably centuries older. So while the lake's location and shape might seem like a cosmic bullseye, it looks like it's just a coincidence.
Wow. It's amazing how science can unravel a mystery, even one as big as Tunguska. So where does that leave us? We've got a massive explosion, flattened trees in a butterfly pattern, no crater, microscopic space dust, but still no definitive answer on whether it was an asteroid or a comet.
And that's what makes the Tunguska event so captivating. It's a giant cosmic puzzle that continues to push the boundaries of our understanding. Every new study, every analysis of those tiny metallic spheres, every computer simulation, it all brings us a step closer to uncovering the truth.
It's kind of humbling, isn't it?
Yeah.
This massive event over a century ago still has us scratching our heads.
Yeah.
It really makes you think what else is out there hurtling through space that we haven't even seen yet.
That's the big question, isn't it? And it's one that scientists are working hard to answer. Today, we have telescopes scanning the skies, looking for potentially hazardous asteroids and comets. And we're even developing technologies to deflect those objects if they were ever on a collision course with Earth.
That's reassuring. I'm glad someone's paying attention up there. Well, you've given us plenty to think about. To all our listeners, next time you look up at the night sky, remember the Tunguska Event, a powerful reminder of the mysteries the universe holds and the importance of scientific curiosity in unraveling them.